Hi, ladies and gentlemen. We're going to get started today. Today is April 13th. If you guys can take out your sheet of loose leaf for your bell ringer for this week, okay, put today's date, April 13th, or week of April 13th at the top. And then you are recording today's date, April 13th, 2021. Okay, and you are recording the bell ringer question, what is a fossil? Okay, so feel free to look up what a fossil is if you're unsure. Okay, so you can Google that. And today during class, we'll be taking a look at some sample fossils. Okay, so if you guys want to pause the video right now, you can pause the video, get that bell ringer question answered. All right, ladies and gentlemen. So today what we're going to be completing, once you have that bell ringer question answered, don't forget date, question, and the answer for the bell ringer. Hey, we are starting today with the Barbellus lab. And then if you finish with the lab, you are going to be working on the toothpick fish lab. If you didn't turn that in or didn't finish it last week for some reason, you are finishing that up and turning that in today. Also, your bell ringers from last week, if for some reason you didn't get those turned in last Friday, you want to get those turned in today. Don't forget there was a bell ringer on Friday, so make sure you include that bell ringer. And then last but not least, the Leopard 6.2 Science Notebook that is due today. So that needs to be submitted today. So at the end of class, if you still have time after the lab, you're welcome to work on one of those things. If there's something you still need to finish up, go ahead and get it finished up and get it turned in today. And then the last thing is the evolution Quizlet. There's a link on Google Classroom. Use that link to help you practice the vocabulary from this unit if you have time at the end of class. Hey, I don't think you guys have a whole lot of time. And then the last thing on here, protein synthesis quiz retakes are due by Wednesday of this week. So if you plan on retaking, you want to get that taken care of by Wednesday, by tomorrow. All right, ladies and gentlemen, let's get to it. So we're going to start off with just watching a little quick video together. This is Fossils Rockin' the Earth. Okay, let me see if I can maximize this.
How do we know that two species are related if their common ancestor is no longer alive? How do we know what happened on Earth before humans showed up? Sometimes the answers to questions like these are right beneath our feet.
Get us some sound.
Look in the right place and you'll find fossils.
Sorry about that. Alrighty, people, here we go.
Two species are related if their common ancestor is no longer alive. How do we know what happened on Earth before humans showed up? Sometimes the answers to questions like these are right beneath our feet. Look in the right place and you'll find fossils, traces of organisms that were once alive and that with time were preserved, usually in rocks. And here's the remarkable thing.
When we get fossils out of the ground, they have features that are shared with features found in living organisms.
So tucked away inside rocks that are thousands or millions of years old, we find fossils of bones and shells and leaves that resemble those in organisms alive today. They give us a record of how life on Earth has changed over time. It's not complete, however, because not all organisms get preserved and not all fossils get found.
So the more of these fossils we have that we can place.
So that's super important. Okay, so when we take a look at our fossil record is incomplete. Okay, we haven't found every fossil that's out there. And then the second point that was super important is that there are some organisms that don't fossilize, and they might not fossilize because the conditions aren't right, or they might not fossilize because they might have soft bodies. Okay, and so usually it's the hard body parts of an organism that are going to fossilize.
Place on the tree, that more tells us of when different features of organisms evolved.
Pull a fossil of a dinosaur femur or thigh bone out of a rock layer that's, say, 68 million years old, and you know that dinosaur must have lived about 68 million years ago. And you can compare it to the femurs of animals both extinct and alive today, which will give you an idea of how those organisms are related, and how the femur in particular has been adapted to suit new organisms in new environments over and over again. The fossil record provides strong evidence for evolution. It shows us that evolutionary change tends to be gradual. It gives us physical proof of extinction and of single species splitting into two. And it contains creatures that are transitional forms between one group of species and another.
Okay, so all of those points are also super important. Okay, so when we look at the fossil record, it gives us evidence of extinction, right? That's how we know that dinosaurs existed. Okay, and they no longer exist today, right? So they have gone extinct. Okay, there are also what are called transitional forms, or we're going to call them missing links. So missing links are organisms that would connect to other species. So a species that is more recent to a species that's older. Okay, and a transitional form would kind of link them together. And that means that transitional form would have characteristics of the older organism, okay, and maybe some maybe less complex feature, okay, of a characteristic or a trait that is found in the later organism. Okay, so it's an in-between organism, right? So if it's in between, it's going to have characteristics that were found in the earlier organism, and then simpler versions of characteristics that are found in the later organism. Okay, so what you guys are going to be doing today is working with an organism called Barbellus. Okay, so Barbellus is the genus that we are going to be working on. Okay, so let's take a look at some intro info. Okay, so first of all, when we are looking at Barbellus, it tells us, hey, fossils are the remains of organisms that lived a very long time ago. They allow us to learn about living things that no longer exist for us to study while they were alive. We can use the fossil record to see what organisms lived during different periods of geologic time. Okay? If fossils exist for groups of very similar organisms, scientists can figure out where the different organisms lived. We can compare the fossils and arrange them in an evolutionary tree. And the tree shows how the organisms are related, just like kind of like your family tree would. Okay, so fossils give us clues about the physical appearance, right? So the fossils can help us figure out what physical traits an organism had, and then they can help us figure out what kind of environment then that organism would be adapted to. Right? And then the last key point in this intro is that fossils are usually found in layers of rock called strata. Okay? Older layers are found underneath newer layers. So older fossils are buried beneath fossils of organisms that lived more recently. Okay, so that is super important. Hey, that's related to the law of supposition. All right, people, so let's get started on the lab. Okay, for the lab, you guys are going to, first of all, need the lab instructions, okay, which are on the green sheet. Okay, and let me share my other screen with you guys so you guys can see what I'm talking about here. Okay, so you should, okay, and you can pause the video right now if you need to. Okay, you should have a copy of our lab instructions here. Let me spread out my camera a little bit so we can see hopefully a little better. Okay, so here are your instructions. Okay, you'll see the procedure starts down here at the bottom of the first page. Okay, the first step in the procedure, so please follow along with the procedure. Some of the things you're going to need to use today are going to be colored pencils and scissors, possibly a ruler and construction paper. Okay, so the colored pencils are at the front of the room at the table in the front on the left-hand side, okay, like they've been previously. The scissors are on the counter, okay, if you're looking at the front of the room to the left. Okay, please, once you use the scissors, hey, please wipe them down, clean them off before you return them to the bucket. So use the wipes that are on the front table. Okay, and the construction paper and the rulers are also on the left-hand side. Okay, but initially, All you need is the instruction sheet, okay? And then you are going to get a copy of the rock strata, okay? And this is, if you think about when you're driving through like Glenwood Canyon or something like that, you'll see different rock layers. Okay, so each rock layer is composed of different minerals. And because it's composed of different minerals, it might have different coloration. Okay, and so around here, okay, it's pretty common for us to see, okay, rock that's kind of red in color. Okay, and so what you guys are going to do, and you guys can choose your own colors, whichever one makes the most sense to you. Okay, but I am going to kind of color in this top layer. Okay, and I'm going to use kind of a reddish color, and then usually the rock isn't totally red, so I'm going to add in a little orange. Okay, maybe for this top layer. Okay, you guys are going to color each layer, and you'll see they're labeled over here on the left-hand side, A, B, C, D, and E, and F. Hey, you're going to color each label or each layer, each rock layer or each strata a different color. Hey, the color should be something that makes sense, that's an actual color that we could possibly observe out in the environment in terms of rock layers. So try to make it as natural as possible, but also vary the colors. It might even be that, some are slightly darker than others, but you're using the same colors. Okay. But you are going to color those different rock layers. So I'll give you a second to get each rock layer colored. Hey, you can also come up and color. Hey, you'll see up here, this is the actual surface, right? So on the surface, hey, we've got some bushes and trees. Okay, some grasses. Okay, so you guys can also color this top layer, or this is the surface, right? This is what we're walking on. Okay, so when we talk about these rock layers, hey, this is the stuff that's underneath, and we see them like through our canyons, okay, but it's also below our feet. Okay, so these layers are also found below where we walk. Okay, you guys can't see the color very well in here, but I promise you, I am coloring. Okay, so go ahead, color those different rock layers. Once you're done with the different rock layers, go ahead and restart the video. So I'm going to pause for a minute while I get mine finished. Maybe. All right, ladies and gentlemen, so hey, you should have now your different rock layers, and each rock layer should be colored in. Okay, so I've got my different layers here, and I've got my surface layer colored. Okay, so now I'm ready to go with that. I can kind of put that off to the side for a second. Hey, you guys should put your name on here just so you keep track of it. Okay, so Mrs. Ulmer up here at the top. Okay, so I've got my rock layers. I'm going to put that off to the side, and then I'm moving on to step 2. Okay, in step 2, if you guys take a look at this page, these are the fossils of the Barbellus species that have been collected from a particular area. Okay, so let me describe to you or explain what I'm talking about in terms of a species. Okay, most people know that a wolf and a dog are very closely related. Okay, so wolves and dogs, are in the same genus. Okay, so they're different species, but they're in the same genus, right? So we've got our dogs that live in our house, and they share a lot of characteristics with those wild wolves. Okay, well, this is fossils from a genus called Barbellus, and then you'll see that each Barbellus has its own scientific name. Barbellus quadrupedus, Barbellus opticus. Here's another one of Barbellus opticus, so we found that fossil twice. Barbellus dorsalis, Barbellus aquaticus, Barbellus caudatus, Barbellus flexilis or something like that. Barbellus long corpus down here at the bottom. Barbellus primordius, Barbellus hirsutus, and Barbellus subterraneus. Okay, so those are the different species of Barbellus that we found. Okay, and because they share some characteristics and traits, they're together in the same genus. Okay, but each one is slightly different. It's got some unique characteristics or traits, which makes it separate species. Okay, so what I'm going to do next is I'm going to cut out, hey, these little Barbellus fossils so that I can take a look at them individually. Okay, so I'm going to do that right now. Let me pause the video and then I'll come back with them cut out. All right, so you should have, if you haven't, you should have each of your fossils cut out at this point. Okay, so if you haven't, please pause the video, make sure that all of your fossils are cut out. You should have 11 different fossils, so make sure you keep track of them. Okay, and now what you're going to start doing is you're going to use your rock layer here, okay, to help you figure out what's the connection between all of these species. How are they related? Okay, and you're going to try to create the evolutionary story for Barbellus. Okay, so I'm going to start down here in my oldest rock layer. Okay, so rock layer F. Okay, and in rock layer F, we find Barbellus primordius. So the B is an abbreviation for Barbellus. Okay, so I go and take a look at my fossils, and I find Barbellus primordius. Okay, so he is going to go in the bottom of my family tree, okay, or the bottom of my evolutionary tree. Okay, then I take a look at what's next. Okay, the next rock layer is rock layer E, and in rock layer E, there are two organisms, Barbella opticus and Barbella dorsalis. Okay, so I find Barbellus opticus and Barbellus dorsalis. Okay, so in taking a look at this, you can see some similarities between this ancestral species, okay, an older species, and his or her descendants. Okay, so the descendants, right, came from, okay, this ancestral species. And this is the concept of descent with modification, right? They descended from Barbellus primordius, but they have modifications. There are differences. Okay, so we can take a look at some of the structural differences that we see here on dorsalis. Okay, we can see some of the structural differences here on opticus, okay, with his large eyes. Okay, you can see the presence of these long antennae versus kind of short antennae. Okay, so we want to be making comparisons, what's similar, okay, and what's different about these organisms. Okay, so this is the beginning of my evolutionary tree. Okay, so I'm going to continue from here. Okay, I'm going to move these guys down. This is rock layer F. This is the fossil that was found in rock layer F. These were the two fossils that were found in rock layer E. Okay, and then I take a look at rock layer D. Okay, Barbellus quadrupedus, Barbellus aquaticus, and Barbellus longicorpus. Okay, were all found in rock layer D. Okay, so let's take a look. Okay, Barbellus longicorpus is this guy. Okay, and so I'm looking at this guy and I'm saying, who does he resemble the most? Okay, I'm trying to infer the relationship between these organisms based on their structural features. Okay, so do you think he looks most like this guy? Do you think he looks most like our common ancestor down here at the bottom? Or do you think he looks most like Barbellus opticus? Okay, and whichever organism you think he looks the most like, I'm keeping my organisms in these different layers. So this is my bottom layer F. This is layer E. Okay, and then this is layer D. Okay, so you place it wherever you want. Just don't move it down. You know, if you think it's most closely related to Primordius, hey, that's fine, but keep them in the layer that's up above. Okay. If you think he's most closely related to dorsalis, keep him over here, opticus over here. Okay, and again, you're looking for structural similarities, whichever one you think he looks most like. And then you're going to have to provide some evidence. You're going to have to support that decision when we get to our conclusions. Okay, so I'm going to put him here for right now. Okay, and like I said, you choose. There's not one way to do this. Hey, then I have Barbellus aquaticus. Hey, that's this guy. Hey, Barbellus aquaticus is this one. Okay, and again, I'm going to do the same step as I did before. Okay, does he look most like Barbellus dorsalis? Does he look most like Barbellus primordius? Does he look most like Barbellus opticus? Hey, and I think this one's pretty obvious, right? He looks a lot like Barbellus dorsalis. So I'm going to put him over here. Okay, and when I say he looks a lot like him, the idea is that Barbellus primordius evolved, okay, mutations occurred. Those mutations led to adaptations that were beneficial, okay, in the environment that this guy lives in. Okay, and the environment that this guy lives in might be different from this one. Okay, which is why there are different traits in this organism. Both of them evolved from the same ancestral species, but because they were in different environments, okay, there were different selective pressures. There were different traits that were favored, and in this environment, having large eyes, okay, is more valuable or was better, okay, for survival, okay, than it was in this environment. In this environment, it became valuable, okay, to have these fins, right? And so you want to think about, well, why would that be? Hey, what would be the difference between those two environments? Okay, and you continue this process for the rest of them. Okay, so then we've got quadrupedus is this guy. Okay, which one does he look the most like? Does he look the most like opticus, primordius, and dorsalis? And again, it's completely up to you. They could all be right here. Okay, you could put all three of them, okay, so that they all branch off, okay, and this would be called adaptive radiation. They all branch, okay, off of Barbellus dorsalis, okay, if that's what you think, okay, that's the way you want to set it up. Or maybe you think, hey, this guy and this guy both, hey, maybe they link back to Barbellus primordius. Okay, so you decide what connections you think these guys have. Then you move up to your next layer. Okay, your next layer is caudatus and hirsutus. Okay, so I'm going to put these two guys, and again, this guy looks a lot like that guy, so I'm going to put them real close together. This guy, who does he look the most like? Does he look the most like one of these? Or does he look more like something in an earlier generation? In which case, hey, if he looks maybe most like this earlier generation, I'm going to leave some room, hey, when I create my tree, so that way I can connect him back to this ancestral species. Hey, then I go up to my next layer. Hey, rock layer B has no species in it, so I'm going to kind of leave a gap or a space. And then I'm going to go up to rock layer A. Okay, and in rock layer A, I'm going to kind of scoot these down a little bit here. Okay, see if I can fit, okay, another rock layer in here. Okay, remember, rock layer B, okay, is empty, so leave a space. Okay, I'm just going to try to shift everything down here. Okay, and these three guys, okay, I'm looking for who do they look the most like. Hey, this is Barbellus opticus. Well, he's already on here. Okay, so they look identical, right? So they've got to be connected. Okay, then I've got Barbellus flexilis. Hey, who does he look the most like? Hey, where should I connect him? Which one of these species? And it could be anything below him. Okay, and then we've got Barbellus subterraneus. Again, who is he most closely related to? Look at the structures he has. Okay, and try to think about what environment would favor those traits or those structures. Okay? Once you have, and again, I'm going to leave a space here in layer B. Okay? I'm not saying this is the way to set it up. This is an example. You easily could have it set up a different way. Maybe it's more like this. Okay? But the key thing is these organisms all have to stay in this row. Hey, these organisms all have to stay in this row. Hey, the organisms here, they have to stay in this row. Hey, and then we have our top layer up here. Those organisms have to stay in that row. Okay, and remember this is going to be rock layer B. I'm leaving a gap there, nothing officially fossilized there, or we haven't found it yet. Okay, go ahead and create your evolutionary tree the way that you think it looks the most, makes the most sense. Okay, once you have it completed, you can go ahead and, well, pause the video now, and then once you have it completed, you can go ahead and watch the video again or hit play. All right. All right, so once you have your species set up here in your evolutionary tree, what you are going to do, make sure that you have your different rock layers, and you are going to transfer them onto a piece of construction paper. You are not going to use the construction paper until you are certain of how you want to lay out your evolutionary tree. So make sure it's set up first, before you start to attach anything, to this construction paper. You are going to use glue. There are glue sticks on the counter on the left-hand side. So that's where you are going to that's where you're going to get the glue to attach these. And the other thing, make sure when you put them down, you're going to put them down neatly. So you want to try to, make them so that they're as squared off as possible. The other thing is you are going to draw lines connecting them. And so the lines that are connecting them are showing or are essentially saying this organism evolved into this organism. And again, that's slowly over long periods of time. So you might use a ruler, and connect your organisms. So I might connect these two. I'm using a pencil to start off here. I draw my little arrow, showing I believe this organism evolved into the next one. And then once I have that taken care of, it kind of in pencil, I'll fill it in pen, so we can see it a little better. You also want to title this page, so you can put Evolutionary Tree of Barbellus or Evolution of Barbellus, something like that. Don't forget to leave that space for rock layer B. So make sure you've got room for rock layer B in between here. Okay, so you've got this gap, and I didn't leave room, so I'm going to do it right now. I've got this gap. So my next step is going to be to look at my species and say, if there was a new fossil that was found, you are a paleontologist, you are out, searching for fossils. If there was a new fossil found, and that new fossil linked an organism from an earlier layer to an organism from the top layer, how would they be connected? Or what traits do you think that in-between organism would have? Okay, so what you're going to do on a piece of scrap paper, you can use like what was left over from your Barbellus fossils, or you can use a separate sheet of paper, separate sheet of white paper, or I've got a little sticky note here. You are going to use a little piece of paper, and I am going to draw what's called a transitional species. So this is in rock layer B. And I'm going to try to draw something. I think that Barbellus flexilis is somehow connected to Barbellus longcorpus. I think they share some similarities, but they also have some differences. Okay, and so there are some things that Barbellus longcorpus, if you can, I'm going to scoot him up here for a second. Okay, there are some things that he has that are missing, okay, in Barbellus flexalis, but I think maybe they were related. Okay, and again, you can choose any of these species up here, okay, and look for what organism do you think links them or connects them, okay, to an organism in the past. Okay, so in an earlier rock layer. So because I'm not a great artist, right? I'm going to do my best, but it might not turn out perfect. Okay, so I've got this little guy. He's got, some twisting kind of body shape like I see in Barbellus flexalis. Okay, but he doesn't end up quite as long. Okay, he maybe is a little shorter. Okay, so his tail is not quite as long, maybe. Okay, and again, you guys are bearing with Mrs. Ulmer because she's not a great drawer. Okay, and I keep that in mind when I grade your stuff too. Okay, he's got a couple antennae. Okay, and so does this guy. Okay, and I think maybe what happened, a transitional species, hey, maybe had something in between here and here. This guy's got pectoral fins. Hey, this guy has little like legs. And so I think maybe the transitional species didn't have these fins. Maybe it actually still had, hey, these legs. Okay, and the legs could be the same or they could be some similar design. Okay, and I've got my other little guy here. Okay, and little. Okay, and so maybe that's what my guy looks like. Okay, you're probably going to draw something that looks way better than Mrs. Ulmer's drawing anyway, right? Okay, so try to make it neat. Okay, but again, it should show some effort in terms of drawing, but I understand if you aren't an artist, like I am not, obviously, right? Okay, so I've got this in-between guy, and I am also going to name him. He is Barbellus, maybe cork screw. Okay, so you guys are going to do the same. Come up with your intermediate or your transitional species. All right, ladies and gentlemen, once you've completed that, then you guys are going to move on to, you've got this all glued down. Okay, then you are going to move on to your conclusion questions from your lab. Okay, so you've gone through all of these procedures. Okay, and then it says answer the following questions thoughtfully and thoroughly. Okay, using the rock strata and your evolutionary tree. Okay, so you guys are going to go ahead and answer the questions on your conclusion question if you finish the rest of this. All right, ladies and gentlemen, thanks so much for your patience. Sorry I can't be with you today.